Hi everyone, and welcome to the Day 2 Notes, Dividing Polynomials. Today's lesson is going to be dividing a polynomial by a monomial, and then we're also going to do long division of polynomials. So there's four terms that describe the four numbers in the division problem. The dividend is the number that's being divided, so say I had 8 over 2. So 8 would be the dividend, because it's the one being divided. The divisor is the number that the dividend will be divided by, so in this case 2. The quotient is the number of times the divisor will go into the dividend. So it's when you divide it, the total number of times it goes in. So in this case, it would be 4. The remainder is a number that is less than the divisor and is too small to be divided by the divisor to form a whole number. In this case, 2 goes into 8 an even amount of times, so the remainder is 0. If it was 9 over 2, it would equal 4, remainder 1, because there would be 1 left over. It doesn't go in an even amount of times. Okay, so the first thing we're going to do is divide by a monomial. So in this case, we have a polynomial, 5a squared b minus 15ab cubed plus 10a cubed b to the fourth, and that's being divided by 5ab. So you should notice that 5ab is a common denominator. It's underneath all the three terms on top. So what we're going to do is we're going to separate every single term on top. So we're going to do 5a squared b and put that over 5ab. Then we're going to have minus 15ab to the third over 5ab plus 10a to the third b to the fourth over 5ab. We're going to simplify every single one of these terms like we did in the past. So if I had 5a squared b over 5ab, the 5's cancel. A is bigger on top, so it's going to be a, and then the b's cancel. Minus 15 divided by 5 is 3. The a's cancel. B to the third over b is b squared. Plus 10 divided by 5 is 2. A to the third over a would be a squared, because again, remember we subtract the exponents. And then b to the fourth over b is b to the third. And that is our final answer. I would like you to pause the video and attempt part B on your own. Now notice that the notation here is a little bit different because it's 3xy to the negative 1. Also recall from the first section that we did in this chapter, if something is raised to the negative 1, it's not happy, it has to move to the bottom, so it becomes over 3xy. Because the notation could be given to you several different ways. The first way where it's actually divided by it, and then another way is where it's multiplied by the monomial to the negative first power. So go ahead, pause the video, and check your answer. Okay, so you should have gotten 6x plus 9x squared z squared. If you didn't, please make sure to ask in class tomorrow. The second part of today's lesson is long division, and you use long division when your divisor is more than one term. In this case, it has two terms. So we're going to set it up the way we would long division with all numbers. The x minus 3 goes on the outside, and on the inside you put the dividend, which in this case is x squared plus 7x minus 30. One thing that you do have to be careful of is that you have all your terms of x. So if we start with an x squared, we should have an x term, which we do, and then you should have your constant term, which we do. So now what you do, and I'm going to compare this on the side to long division with constants. So let's say I had 1,893 and it's being divided by 53. With numbers, what you do is you look at that 53 and see where does it go into. It doesn't go into 18, but it does go into 189. How many times would it go in? 3 times. So you put that number up on top. With polynomials, what you do is you take the x and you divide it into x squared. So here what you're going to put is the x squared divided by x. The value of that, in this case, it would be x. Back to the number part. If you have this 3 on top, what you do is you multiply it by that 53. That would give us 9 and then 15. Same thing with the polynomial. We're going to multiply x by the divisor. We would get x squared minus 3x. Back to the numbers, what do we do in this case? We subtract. We would get 0 and a 3, and then you bring down the next digit. In this case, it would be a 3 that we bring down. So we're going to do the same thing here. We're going to subtract this polynomial. Now here's where most kids make their mistakes. They'll subtract this part fine. X squared minus x squared, gone. And that part should always be gone. That first term needs to cancel out. Then what you have is 7x minus a negative 3x gives us a positive 10x. The most common mistake is that kids will write that it's 4x because they just look kind of down the column. They're like 7x minus 3x, that's 4x. Remember, you have to distribute that minus sign. 7x minus a negative 3x. And just like over here on the right with the numbers, we're going to bring down this minus 30. Oh, back to the example on the right with just numbers. Once you're at this point, you now are always asking yourself, how many times this 53, how many times will it go into 303? You don't look back into the dividend, that original 1,893. You now have this new number that you're going to be dividing 53 into. So how many times will 53 go into 303? The answer is 5. So over here with our polynomials, same thing. You never look back to that original polynomial that was the dividend, that x squared plus 7x minus 30. You are now looking how many times will x, and you don't do the x minus 3, you ask yourself, 10x divided by x, what would that give you? And that answer goes up top. Just like the 5 went up top, we're going to do 10x divided by x, and that answer would be plus 10. Looking back to the number part example, once we get this 5 on top, what you do with that is you take 5 and you multiply it by the divisor 53, which would give us 265. And once we get 265, you subtract it from 303, giving us 38. Okay, back to our example with the polynomials. That 10 up top, we're going to multiply it by the divisor, x minus 3. Make sure to distribute. We will get 10x minus 30. And just like with numbers, we take that and you subtract that entire quantity away. So as it should happen, that first piece goes away because 10x minus 10x is nothing. And then you have negative 30 minus a negative 30. So don't write that that's negative 60. It actually is 0. Number part, 38. So you're checking how many times does 53 go into 38. It doesn't go into it a whole amount of times, so this would be our remainder. And the way we're going to be writing our remainders is you're going to say that this is 35 plus 38 over 53. I know we don't normally write that with numbers, but that's our answer. So our answer is up here on top. 1,893 divided by 53 is 35 plus 38 over 53. Back to our polynomial, we have a 0. X does not go into 0 anymore, so this is our remainder. And if your remainder is 0, you do not need to write that as plus 0 over x minus 3. But let's say our remainder was something like 7. Our answer would then be x plus 10 plus 7 over x minus 3. But there is no remainder, so our answer for this problem is x plus 10. Okay, let's go ahead and do example B over here. So we have 10y to the third minus 20y minus 10 times 5y plus 5 raised to the negative 1. If there's a quantity that's raised to the negative 1, that whole thing would shift to the bottom, becoming division. So this is long division of polynomials. So we're going to write the divisor outside, 5y plus 5, and the dividend goes inside. It's 10y cubed. Now, notice what I said before. You have to account for every value of y that's lower than what you start with. So we're starting with a y to the third. We don't have a y squared. We have to account for that. This is called a placeholder. We're going to put a plus 0y squared. And then we have our y value minus 20y, and then our constant minus 10. All right, so let's start this one. First thing you do is you look to the dividend, and it's 10y to the third, and we're going to divide that by 5y. So if you need to, go off to the side and do that. 10y to the third over 5y, what would you get? 10 divided by 5 is 2, and then y to the third divided by y is y squared. Next step, you take this number up top and you multiply it by the divisor. So 2y squared is going to get multiplied by 5y plus 5. So we're going to get 10y to the third plus 10y squared. Next step, subtract. And we will get 10y to the third minus 10y to the third cancels out. That's good. That means we did it correctly. And then 0y squared minus 10y squared is negative 10y squared. Bring down the next term, it's minus 20y. Okay, so again, most important part, because a lot of times that first step is pretty successful, and then I notice that kids get stuck. Remember that you never look back to the original polynomial. You look to this new one that you got as an answer. So you're going to check how many times will 5y go into negative 10y squared. You divide those two. So again, off to the side, you could do negative 10y squared. Divide that by 5y. What would you get? Well, negative 10 divided by 5 is negative 2, so we're going to write it as a minus 2 up here. And then y squared divided by y is y. The new number up top gets multiplied by the divisor, so we're going to do negative 2y times 5y plus 5, giving us negative 10y squared minus 10y. Subtract that whole quantity away. Negative 10y squared minus a negative 10y squared, a double negative becomes a plus, so that cancels out. That's a good sign. And then negative 20y minus a negative 10y, that becomes a plus 10y, so negative 20y plus 10y is negative 10y. Bring down the next term. It's negative 10. Again, never look back to the original. We're taking the first term here of what we got, and we're going to do negative 10y divided by this first term, 5y. Do it off to the side if you want. Put that answer up top. So negative 10 divided by 5 is negative 2. Y over y, the y's would cancel. So now take that number up top, multiply it by the divisor again. We're going to get negative 10y minus 10. Subtract that away. Negative 10y minus a negative 10y would become negative 10y plus 10y. That's gone. That's good. Negative 10 minus a negative 10 happens to be 0. So we put that answer down here. So our remainder is 0. Final answer then is up top. It's 2y squared minus 2y minus 2. Because the remainder is 0, we don't have to write anything. If that number, that last number over here, if that was like a 7 or something like that, we would write plus 7 over, and it's always over the divisor, so it'd be 5y plus 5. No remainder though, so that's our final answer. Okay, so for part C, I will start you off, and I will let you know that your final answer, you will have a remainder that's not 0. So you are going to have to say plus whatever that number is and put it over the divisor. Okay, so the divisor goes on the outside, x minus 1, and we are dividing x squared minus 13x plus 4 by it. Notice I started with a power, my first power of x with the dividend was x squared, and then I have to account for every power of x from there. So we have an x to the second, an x to the first, and remember a constant is like an x to the 0, because x to the 0 is 1, so we have it. Okay, so now we take the first term here, x squared divided by x. If you could do that in your head, fantastic. X squared divided by x is x. Number up top always gets multiplied by the dividend, so we would get x squared minus 1x. Okay, I'm going to stop helping you at this point. Remember, your remainder is not going to be 0, it's going to be some kind of number. So pause the video, finish this problem, and check against my answer. Okay, so here's our answer. You should notice that our remainder, or hopefully you got it on your own, that the remainder is negative 8. So you could write it two different ways. I wrote it both ways for you. X minus 12, and then with the remainder being negative 8. You could write it as plus negative 8 over x minus 1, or you could write it as x minus 12 and then minus 8 over x minus 1. Please don't write a double negative. Don't subtract a negative 8 over x minus 1, because then that would be a plus 8. And that was not our remainder. Our remainder was negative 8. Okay, so there you have a long division of polynomials. I hope you enjoyed it as much as I did. Have a good one.